Good morning, friends. Today I will discuss combined translational and rotational motion of a rigid body. Suppose there is a body or disk whose center of mass is say this point O. It is in translational as well as in rotational motion. Suppose this disk whose center of mass is rotating with linear velocity v center of mass, and it is rotating with angular speed omega. Its radius is say r. Now this is the case of combined translational and rotational motion. Here center of mass is translating with a speed v center of mass, and simultaneously this disk is rotating with angular speed omega. So this such type of motion is called combined translational and rotational motion. Now our aim is to find number one, velocity of any point on disk, and second parameter we will discuss today, x and y coordinates of bottommost point. So first I am discussing velocity of any point on the rigid body. So first parameter we are discussing on velocity. Suppose this is disk whose center of mass is translating with a speed v center of mass, and it is rotating with angular speed omega, and its radius is r. Now due to this translational motion, every particles on this part is in a linear speed v center of mass, and due to rotational motion its different parts is having angular speed omega into r. So this motion can be converted in equivalent to one, that is it is translating with a speed v center of mass, plus simultaneously this disk is rotating with angular speed omega about center of mass. So velocity of any point means it is the resultant of velocity of center due to translational motion as well as due to rotational motion. So just suppose we have to find say a speed of this point. So now this point having two velocity. One is due to translation, this is equal to v center of mass as equal to velocity of center of mass, and second one is due to this rotational mass. So this is equal to omega times r. Omega into r is distance from this center of mass. So this velocity is omega into r. Now this velocity magnitude is omega r, and it is perpendicular to the line joining the center of mass to this point. So this angle is 90 degree. So this point having two velocity, one is along this due to translational motion, and this is due to rotational motion. So resultant velocity will be vector sum of v center of mass and omega r. So this is the resultant velocity. Now suppose we mark 4 different points and we want to try how to find the velocity of different points on the disk. So we are taking 4 standard points. One is at say A, another one is at this point is B, and this is point C, and this point is D. And this disk is rotating with a speed say angular speed omega, and its translational speed of with center of mass v center of mass. Now come to point A. This point having one velocity due to translational motion, that is v center of mass, and second one is due to rotational motion, that is omega times perpendicular distance between point A and center of mass O. So this distance is r. So its speed is omega into r and perpendicular to this one, that is this omega r. So net velocity at point A is equal to v center of mass plus omega into r. Now come to point B. This point B having v center of mass due to translational motion and another one velocity that is due to rotational motion is omega into r, and this is perpendicular to this line. So resultant velocity will be this one, that is its magnitude is equal to under root v center of mass का square plus omega r का whole square. If you come to point C, अगर हम लोग पॉइंट सी का बात करें तो यहाँ पर एक वेलोसिटी होगा ट्रांसलेशनल मोशन के कारण, दैट इज वी सेंटर ऑफ मास, एंड रोटेशनल मोशन के कारण दैट इज अपोजिट टू दिस वन ओमेगा आर. सो वेलोसिटी एट पॉइंट सी इज इक्वल टू वी सेंटर ऑफ मास minus omega into r. Similarly, at point D, we have one velocity that is v center of mass due to translational motion of center of mass, and another one is line joining this point perpendicular to this one, that is omega r, and resultant will be Vd, whose magnitude is equal to under root v center of mass plus omega r का whole square. So in this way we can find the velocity of any point on this rigid body. Method is just you give the equal velocity in magnitude and direction of center of mass, and second one is due to rotational motion, that is omega into r, where omega is angular speed of this disk and r is perpendicular distance of the point from the center of mass, and vector sum will give the velocity of that point. So this is the method how we will calculate the velocity of any point. Now come to second parameter, that is calculation of x and y coordinate of, second is calculation of x and y coordinate, x and y coordinate of coordinates of bottommost point, bottommost point. So suppose this is the disk which is translating with say speed v and it is rotating with angular speed omega. So at t equal to 0, suppose this is the line, we have taken this as a y-axis and it is moving like this one. So after time t, it will come to a new position at this point. So this is the center of mass which is in pure translation, that is in time t, it will cover a distance equal to v into t. So this distance will be equal to v into t. Simultaneously this disk is rotating. So as well this center of mass will come to this point, this disk will, this bottommost point will rotate with angle say theta, and theta is equal to omega into t. So this is the coordinate or position of bottommost point A after time t, that is A dash. Now we have to find the coordinate of this point. So coordinate of this point means this is x coordinate and this is y coordinate. Now come to this one. This distance is Vt, and if we draw perpendicular on this point, so this distance is say radius r, this is theta, so this distance is equal to r sin theta, and this distance is r cos theta. So x coordinate is equal to Vt, this distance minus this distance, that is equal to minus r sin theta. That is Vt minus r sin omega t. And y coordinate is this one, that is this distance means r minus this distance. So this is r cos theta, and theta is equal to omega t. So by coordinate is r into 1 minus cos omega t. Therefore, at any time t, bottommost point's coordinate will be coordinate of point A. Coordinate of point A will be Vt minus r sin omega t, comma r minus r cos omega t. So this is the coordinate of point, bottommost point A at any time t. Thank you.